Well, good evening everyone. Long time since I've done an upload to YouTube, and just basically sort of been doing the same old thing over and over again, and nothing really worth uploading, to be honest with you. Just sort of repairs on the equipment you've seen before, nothing very exciting. So this is just really a catch-up video, just to say that I am still alive. I haven't died of COVID or anything horrendous like that. I'm just hoping everyone's well and keeping safe and enjoying this rather drab summer. What's happened in the last month? Not a lot. Been working. I've done some alignments on my radios. Some of my radios, my Yaesu FRG 100, which I've been using. My low HF225 that you've seen before. Just sort of checked the alignment on things like that. And just basically tinker around in the workshop. We've had a couple of bits of test equipment fail. One of the pulse generators failed. I repaired that. Nothing particularly interesting. eBay purchases, nothing really, apart from last week. I was just trawling through the sort of like the spares or repair section of the electronics test equipment, which I'm quite interested in, as you all know. And I came across a multimeter that I recognised. I thought, I recognise that multimeter. Had a closer look, and it was a multimeter that I bought back when I was still at school, probably in the, well, it would have been the probably early 80s, I should think, probably 81, 82, something like that. And I bought it from a shop called Servio Radio in Wimbledon. I know a lot of you have heard of Servio Radio. Fantastic shop in Wimbledon. I used to get on the train from New Malden, get on the train, come up, get off at Wimbledon, which was 2 stops. You had Rains Park and Wimbledon, and then walk to Servio Radio, which was about 20-minute walk. And it was like a, how do I describe it? It was on the corner of a road in Wimbledon, just outside of the main town centre, and it was a very old, like an old converted house. And it was packed with old electronic stuff. It wasn't army surplus, but it had sort of it did have army surplus stuff in it, but it was full up with sort of like kits and lots of books. I think they also had, from memory, I think they had sort of model planes and things like that. But they had tools, oscilloscopes. It wasn't any of the sort of high end stuff, but it was sort of like the project sort of person's shop. It was a better quality Tandy, basically. And actually, I used to walk past Tandy and the Wimbledon High Street to get to Servio Radio, and that used to be the stop off on the way back if I had any money left. But I remember going in there. It must have been probably 1980, might even been in the late 70s, but I think it was early 1980s, and with the intention of buying a multimeter. So I went into Servio Radio, and the people in Servio Radio were always very good. They were excellent salesmen, but they were never pushy. They could see I was a school kid with sort of probably not a lot of money. I went in there and I was looking around. He said, "Oh, can I help you with anything?" I said, "I'm just looking at multimeters." And he said, "Oh, you just want a sort of like a good quality sort of average sort of multimeter?" I said, "Yes." I mean, at the time I had a little tiny Panda multimeter. I don't remember those, little tiny thing that had the ×1 ohm range, and that was it. Very limited. And he said, "Well, have a look at the selection here." He said, "There's quite a nice selection of multimeters." And I can remember there were some sort of quite expensive multimeters there. I don't think they were things like the early push-button flukes or anything, but there were some nice meters there, some analog stuff. But I was after an analog meter because the digital stuff at that time was very, very expensive. Even a very basic digital multimeter. Because I mean, Tandy was selling digital multimeters in that time. And they were 25, 30 quid for a pretty basic multimeter. So I had a look round and sort of came across this Altai multimeter from memory, and yeah, sure enough, one of these. It's an Altai YN 360 TR, and I came across one on eBay. And I thought, wow, that's the multimeter. That was my first decent multimeter, and it was up for £4 first bid, and sort of £3 postage. So it's going to cost me less than about eight quid to sort of get it shipped. Anyway, I put a first bid on and just left it at that. I thought I'm not going to put any more on it. It's not that important. It's not going to be the greatest multimeter in the world, but we'll take a punt on it and see what happens. Anyway, digressing, going back to the sort of like when I bought this first multimeter, I bought it home and put batteries in it, and it was like, you know, amazing. It had sort of a lot more ranges. It had a basic HFE transistor tester. It had a current range, which is the little Panda meter didn't have, and it had obviously the selection of different ohms ranges up to sort of like, it would measure resistors up to a meg sort of thing. It had a higher input impedance. I think it was well, I'll check in a minute. I think it was 20,000 ohms per volt, maybe 10,000. I'm not sure, but I remember it, and it was a good meter, and I used it for a couple of years before it sort of like typical Chinese, I think it's Taiwanese meter, sort of like fell apart, and contacts became unreliable. I think by then I was working at a little hi-fi shop in New Malden, and the boss put some money towards and bought me actually I think that was a realistic digital multimeter. So I got that, and then this thing was just probably scrapped or thrown away. So this is the multimeter I bought, and you can see it comes in a box, which is quite nice. And I remember the sort of like symbol, and it's almost like a master's voice symbol on the side, but with a man rather than Nipper the dog. So it's fully boxed, and this is what I wanted to show you this evening. So comes with the original manual, which is nice, obviously, and instructions of how to set it up. And usually these things had a circuit in them. I'm not sure this one has. I'm just having a quick look through, see if we can see if it's got any circuits in it. Shows you how to test transistors, things like that. Yeah, it's a nicely written manual. And it's not in Chinglish, you know. It's actually, you can actually understand what it is. Let's see. Yeah, various circuits inside to tell you how to test various things. It's designed for an amateur sort of person who just wants a multimeter that does everything, and just basic instructions as well. So here's the meter itself. When I got it out of the box, I thought, that's not the meter I bought. It's tiny. But I don't know if anyone else has had this experience. When you had something when you were younger, and you go back to it, like the classic ones I find is if I go to the street I used to live in sort of 35, 40 years ago, it seems to have shrunk. Everything seems to be much smaller than it was. And it's like this with this multimeter. This multimeter I sure was sort of that size. But it is this multimeter, and as you can see, it's in lovely condition. It's got the same clicky switch I remember, and it's actually reasonably well built. It uses the I think is it a 2mm jacks rather than the standard banana jacks, so that's pretty makes it a bit difficult to interface with, but you have to use the original probes. So we've got the ×10 option on the meter. We've got current. We've got the HFE scale around the side, as you can see. And it will measure current up to 1/4 amp. It hasn't got a shunt in it, but it's pretty good, pretty usable for sort of checking transistor stuff. It's got the output terminal, as you can see there, for DC decoupling, and the meter's very nice and clear with a parallax mirror in it. So I think the first thing to do is get it on the bench and see if this thing actually works. Take the back off it, have a look inside. I've got to change the battery on the camera. It's just flagged up that the battery's about to die. Have a look inside, see what it's like, and see how accurate it is, and see if it brings back any memories. Oh, so here's a closer look at the meter. So we've got the amps range down here. So it starts at 50 microamps, 2.5 milliamps, 25 or 1/4 amp, times 1, 10, 100. Times 1 times 10 times 1k times 10,000 on the ohms range. AC voltage we've got 10, 50, 250 and 1000, and DC we got it says 1000, but I think it needs an additional probe for that because it says probe. 250, 50, 10, 2.5 and half a volt, and what's that? That's the microamp range again as well. So yeah, it's down minimum voltage of half a volt. Ohms range adjustment here. normal inputs for the positive and negative, or P and N on the junctions of a transistor, and output, as I say, which is connected to a series capacitor for blocking DC, so you can measure AC waveforms on a DC signal. For example, if you were looking at the output of the signal on a anode of a valve, you could actually use this connection here. It would block the DC in theory. I've never actually used one that's any use, and you should be able to see the AC signal coming through. So if you're on the AC volts range, you should see the meter moving around with the audio. If of course the capacitor isn't leaky, which on something like this it probably is by now. So yeah, it's a pretty sort of standard Taiwanese made multimeter. This one's in lovely condition. It's I don't think it's ever been out of the box. So let's take the back off and have a look, see what we've got inside. So we've got a large sort of like posi drive screwdriver slot on the back. Let's have a look. Remove that and let's see if it's ever been fitted with a battery. There's no battery in it. And it's actually quite nicely made inside, and I seem to sort of remember these being quite nicely made. It's all pretty solid. There's this nice switch arrangement there. Nice solid clunky positive switch. You can see the switch contacts there are sort of like pretty well made. It certainly doesn't look inside. It doesn't look like it's been thrown together like some of the multimeters were. I don't think it's got anything like diode protection even on the multimeter, on the meter. A lot of them used to put a diode across the meter to protect the diode from sort of massive over voltage. Might be able to fit that at a later stage. I'll have a look. There are two diodes here that you see that are part of the rectification circuit for the AC signal. Here's our this capacitor here is the one that blocks the output for the DC. That's connected in series with the output terminal to the positive side. So that's our DC blocker for the output measuring I was mentioning earlier on. It's in good condition. Doesn't look like it's ever had any batteries. However, the battery contacts are a bit sort of like tarnished, but then again, sort of 40 years of sitting around doing nothing, that's what happens. So this looks like it takes our 1.5 volt battery, and I've just spotted something quite interesting. I wonder if someone's actually tried to plug this in and realised the ohms range doesn't work. So this is our 9 volt battery for the times 10 range for the multimeter, and that goes in that slot there. We put 2 and 1.5 volt batteries here for our connections. All right, they're loose, that's not a problem. But what is missing is the connection at the back that puts the two batteries in series. So this is possibly why someone sort of like plugged it in. This has been missing from the original factory equipment, and they plugged it in and it hasn't worked, and they said, oh, the meter's no good, I'll go and buy another one. So that's interesting, isn't it? There's a part missing from here. Now, I don't know if it was just like a riveted sort of strip of aluminium or what it was, but there's no way that this ohms range is ever going to work because we've got an open circuit. That's our positive connection there, I assume, and negatives at the bottom, but we've got nothing at the back to complete the circuit. So that would be one of the first things to put right. But apart from that, I mean, this meter looks virgin. It looks, it's in really nice condition, and it's sort of bringing back the nice clarity of the meter. Look how nicely laid out that is. Really clear, nicely sort of nice fonts, nice color screen. You can see what's AC and what's DC and what's transistor, etc. So let's put a battery in it and make a link up and see if we can actually get this meter to work, because I think that's probably all that's wrong with it. It's just that link missing from the battery. Right, what I've done is I've got some old springs I've cut down and sort of wound them into the holes that are existing there, and then just link them together, and that's made a reasonably good connection. Seems to be fine for the batteries. They're held in. It needed a spring contact to keep the pressure on it, because these are just flat connections. Obviously what it would have had before was like one of the sort of like a bent tab that held the batteries under tension. That's worked. I've also added two 1N4148 diodes back to back, and all they will do is they will offer some protection to the meter in a gross overload situation. I'm surprised the meter hasn't actually got any fitted. So basically these diodes will have no effect on calibration, and I've checked they don't have any effect on calibration, but what they will do is if you exceed 0.7 of a volt across the meter, which will be a gross overload for the meter anyway, they will start to sink the current via this resistor, and therefore hopefully preventing the meter from burning out. So that's just a sort of like a protection component that I've added, a couple of protection components I've added. Cost nothing. I'm surprised they haven't done it. As I say, looking around it, it's all in really nice condition. The switch is actually surprisingly good quality actually. I've gone over with some contact cleaner. I haven't checked any of the resistors, everything seems okay. So we've got a new battery for the times 10k resistance range, and we've got some two new batteries for the lower ohms range. So the next thing to do, I suppose, is to connect it up to a calibrator maybe, and have a look, see if it's worth its weight in plastic. You know, it was a £5 meter. They were £12.95. I think I paid £12.95 in 1982, whatever it was. Let's see if this thing's any good. Okay, let's start with the ohms range, see how accurate it is. So basically we connected up to my Time Electronics resistance decade box, which is extremely accurate and good for calibration. So we're on 0 ohms now, so I just need to adjust my 0 ohm point here. Now this is a bit tricky because I'm doing this upside down, so it's the correct way up for you and upside down for me. So we're on the times 1 ohm range. So let's try this then. Let's try 10 ohms. So no, that's 100 ohms. That's 10. Where are we on the ohms range? Exactly on 10. 20. Good. 30. Good. 40. Yep. 50. Smack on. 60, 70, 80, 90. And then back to 0 again. So let's try 100 ohms. Excellent scale linearity. 200. Yep. that's surprisingly good actually. So let's try it on the 1K range. Reset our 0. So let's try 1K. So 1K. There's 1 there. 2K. Yep. 5K, smack on. 9K. Okay, let's go 10K. 20K, 30, 40, 50. It's surprisingly accurate. 90. Let's try 100. Should be there. Extremely accurate. Far better than I was expecting. Let me zoom in a little bit closer so you can see a little bit easier. Which the meter does tend to flare out a bit. Okay, let's try the times 10 range then. So we reset our 0 again. So 100k. Yep. 200. 3. 4. Slightly going off now. 5, 6, 7, 8, 9. So let's go 1 meg. What's 1 meg show up? Okay, 1 meg shows, well actually 1 meg is, depending where you're looking at the screen with parallax, it's just over 1 meg, which I think is exceptionally good for a meter that's sort of like coming on 40 years old. All right, hasn't been used and would have been a budget meter anyway. The ohms range works really well. So I think the next thing to do is try it on some volts and the currents ranges, see how well it performs on those. All right, let's try this on the volts range. We're on the half a volt range, so I'll enter 0.25 volts, so it should be half scale. 0.25, enter. Fractionally short. No, it's come up half of, yeah, it's more or less, yeah, just slightly short. So, but that's very good, excellent. That's what you'd expect as if it was new. So try it full scale, 0.5 volts. Should be full scale deflection.
yeah, and it's hauling back very slightly. So let's go to the 2.5 volt range, and with half a volt in, you can see it's spot on. Let's try it at 2.5 volts, 2.5 volts. Full scale deflection. Slightly short, as you see, but the meter isn't actually lying flat on its back. It's actually on its tilting bales. It's slightly up about 30 degrees. Let's try it on 10 volt range. So we're on 2.5 volts now. That's about right. There's the 2 volt mark in there. 2.5. Yeah, that's pretty good. Let's try it at 5 volts. It should be half the scale, fraction short, and then try it at 10 volts. Yep, that's more or less smack on 10 volt range. So it's pretty accurate actually, and it's, you know, it's no worse than I'd expect it to be when it was new. You know, there's no degradation, or it hasn't been. I don't think this meter's been used, but it's certainly performing very well so far. A lot better than some of the other analog meters I've got of this sort of era. So let's move on and see if we can do some AC testing. Right, this is the AC range. We're outputting 1 volt at 400 cycles, and it's showing it's slightly short of 1 volt on the 10 volt range, but it's not bad. I'm using 400 cycles just because it's a break away from the sort of normal 50 cycles or 60 cycles. 400 cycles is actually sort of like the standard used in avionics, and so I've just thought I'd try it on that. I don't expect it to be particularly accurate. So let's try another voltage. Let's try it at 5 volts. I think that's at 5 hertz actually. Hold on a second. Enter frequency. Oh, it's asking me for frequency, so let's enter it at 400 hertz. 400. There we go. Okay, so that's 400 hertz, and it's reading slightly high at 5 volts. Let's try 10 volts. So enter, not entirely au fait with this thing. That's the frequency, so I need to go AC volts. Let's enter amplitude 10. Enter. It's banging the meter across. So let's go 400 hertz. Yeah, and it's actually pegged the meter right across. Okay, so that's interesting. So let's reduce the frequency to 50 hertz. Okay. So yeah, it does overread quite a bit on the AC range, but pretty reasonable actually. Better than I was expecting. As I said before, quite pleased with this meter, and it's quite reassuring that the meter that I bought sort of like 35-40 years ago, whenever it was, it's depressing to think actually, is actually not a bad little meter, and it performs pretty well, and for a budget meter performs very well, I think. So yeah, I hope that was of some interest. This was my, as I say, my first proper meter that I ever bought, and I've got a bit of a soft spot for this. So thanks for watching, and more to come.